In today's lesson, 9.3, you are going to learn how to solve quadratic equations. But in order to solve quadratic equations today, and this is today only, you're gonna see equations that do not have a bx term. And that's what you're going to focus on solving. I'll teach you how to solve other ones, but for today, you're going to learn how to solve things that don't have a bx term. Yesterday, we talked a lot about quadratic functions. Today, we aren't changing that. We're just going to call them quadratic equations. So if we have a quadratic equation, we're just going to know that it's going to be equal to something. And it's really not that big of a difference. Your key concept for today is the standard form of a quadratic equation. I kind of want you to circle this, star it, highlight it. When we talk about standard form, we're talking about ax squared plus bx plus c. That's called standard form. And just like standard form was, you knew it in chapter 8, you're going to understand standard form goes in order in chapter 9 as well. Now, if you ever have a standard form equation, you need to make sure to make a note to yourself to always set them equal to 0. Let's flip. One of the essential understandings for today is that quadratic equations can be solved by a variety of methods, including graphing and finding square roots. So we're going to do graphing first today, and we're going to find square roots second today. One way to solve ax squared plus bx plus c equals 0 is to graph it. The solutions are the x-intercepts of the related function. So take a look at the graph they gave us. Notice they graphed it just like we would have graphed it yesterday. Okay, they would have made an XY chart. They would have put the vertex in the middle, and then they would have surrounded it with points. Do you see the x-intercepts? The x-intercepts are what we call the solutions. Notice it crosses at -2, and it crosses at +2. So this one has two solutions right here at the x-intercepts. Now if you're wondering why those are the two solutions, it is because, ready, let's write this down. Given the equation, and what was the equation we were given? Y equals x squared minus 4. Okay, in order to solve it, we would set y equal to 0. Okay, the reason that we'll put 2 and -2 are the solutions because they plug in to equal 0. When you plug them in, because 2 squared minus 4 is 0, and -2 squared minus 4 is 0. Alright, all of that aside, okay, let's move on. A quadratic equation can have 2, 1, or no real solutions. It can have 1, 2, 1, or no real solution. In a future course, Algebra 2, you're going to learn about some solutions that are not real. Those are going to be called imaginary solutions, but you won't get there until Algebra 2. The solutions to a quadratic equation and the x-intercepts of the graph, a related function, are called the, ready for this key word, roots of the equation. And we'll just stop with that. It's called the roots of the equation. That's what I want you to know more than anything. Okay. So, the roots of the equation are where the parabola crosses the x-axis. So let's try this first. Look at the directions. Solve by graphing. I wrote you a little note to replace 0 with y and graph it like we did yesterday. Alright, take a look at problem A. Let's pretend that instead of saying 0 equals, it said y equals x squared minus 1. Just pretend it said y equals. We are going to find the roots. In order to do that, we need to graph. Alright, yesterday you would learn how to find your vertex. In this problem, to find your vertex, you can do negative b over 2a. You know what? But b is 0, isn't it? So we start with 0. B is 0. Now why is b 0? Because there's no x term. Alright, b is 0 because there is no x term. So let's plug in 0. Well, 0 squared minus 1 is negative 1. Now let's surround it. Negative 1, negative 2. 1, 2. Let's plug in the nicer points. Let's plug in 1. 1 squared minus 1 is 0. Let's plug in 2. 2 squared minus 1, well that's 4 minus 1, is 3. You could plug these two in to prove that those are the same. Let's plot our points. 0, negative 1, negative 1, 0, and 1, 0, 2, 3, and negative 2, 3. Make your graph. Okay? And now, do you see those places right here? I'll highlight them with my purple marker. Those are the x-intercepts. Okay, let's write that down. X-intercepts occur at negative 1, 0, and 1, 0. So the roots are x equals, what are the two values? Negative 1 and 1. This one has two answers. Why does it have two answers? Because it crosses 2 times. Let's move on. X squared equals 0. Well, let's pretend that this said y equals x squared. When you make this xy chart, I'm hoping you know right away when you see this that your vertex is 0, 0. But in case you don't, just remember you do negative b over 2a. In this case, b is 0, so you do 0. Put it in your chart. Surround it with the typical values. Plug in your typical values. 0 squared is 0, 1, 4, 1, 4. I'm just plugging those in like we have been. Plot your points. Pause the video if I'm going a little too fast so you can take your time and catch up. Connect. Do you see where it crosses down here? That is the only x-intercept. Let's write it down. X-intercept is 0, 0. Okay, so your roots equal 0, right? Let's say roots are, no, let's keep it consistent. Roots are x equals 0. This one only has one answer. Why does it only have one answer? Because it only crosses once. Let's try it one more time. Part C. Find your vertex so we can graph it. Pretend it said y equals x squared plus 1. Your vertex on this one, I hope you can start visualizing these. Your vertex on this one is 0, 1. If you're not sure why, you do negative b over 2a. b is 0. So plug in 0 and you get out 1. Plug in 0, get out 1. Surround it. And plug those new values in. 1 squared plus 1 is 2. 2 squared plus 1 is 5. And then these are reflected. Those are reflected. Plot your points. Did you guys notice this one just kind of moved up? That's the only difference. And I know I didn't give you enough dots, just pretend I did. Okay, there it is. Pause the video if you need to take your time. Now look at this x-axis. What do you notice about your x-axis? You see how there are no x-intercepts? Okay, that means there are no roots. And let's actually be 100% correct. There are no real roots. In Algebra 2, you'll learn that there are imaginary roots. So you just write no real solution. Now why are there no roots? Because it never crosses. Let's flip. There is another way. If you did not like graphing, which all the time graphing can get very cumbersome, and if you're bad at graphing, you're not going to get the right answers. But sometimes you're going to have like square roots and stuff, and graphing isn't very conducive. Just like it wouldn't be back when we studied two solutions, graphing is not always the best way to find an answer. Alright, another way is to find the roots is to, ready? Write this down. Take square root. Write that down. That's going to be probably easier for you. Here are your steps. Number 1, isolate x squared. Number 2, square root both sides. Step 3, give the answer a plus and minus. Alright, now they give you an example. I kind of would like to walk you through the my example problem too. What are the solutions of 3x squared minus 75 equals 0? Well, step 1 says to isolate x squared. So we're going to add 75 to both sides. That gives me 3x squared equals 75. Now divide by 3. That gives me x squared equals 25. Now step 2, because we isolated x squared, that we finished step 1, step 2 says find the square root of both sides. So put a little square root around the whole thing. The square root of x squared, well that's just x, and the square root of 25 is 5. But that can be a plus and a minus 5. Why could it be a plus and a minus 5? Because positive 5 squared is 25 and negative 5 squared is 25. So you found two roots right away. What does that tell you about your graph if you needed to graph it? You could say it crosses the x-axis twice. You could even say that it crosses the x-axis twice and those points are at 5 and negative 5. So it has two solutions, it crosses twice, and you know the two answers. Let's do this with got A, B, and C. Add 36, so you get m squared equals a positive 36. You have isolated it. Take the square root. M equals plus and minus 6. Part B. Subtract 15, so you get 3x squared equals negative 15. Divide by 3, x squared equals negative 5. Take the square root. Now I'm really hoping you guys know nothing squared gives you negative 5. Okay, write that down. Nothing squared, actually let's just write this down. Nothing squared is negative that you know of. In Algebra 2 you'll learn about imaginary numbers, but right now nothing squared to you is negative. So you write no real solutions. This would never cross on the x-axis. Part C. Take away 16. So you get 4d squared equals 0. Divide by 4. D squared equals 0. Take the square root. D equals 0. Please don't put plus and minus. 0 is 0. There is no positive and negative. This one has one answer, which means it crosses once, and usually and always that's going to be at your vertex. Problem 3. Problem 3 we'll do on another video.